everyone. Welcome to our June Kube Chat. Kubernetes Spin has an ownership problem. Before we dive in, I just wanted to go over some housekeeping. So on your console, you'll see a PDF version of today's deck. So feel free to download that and you can follow us along or use the resource slide at the end to access some of the links that we shared. You'll also see a Q&A feature on your console. So if you have any questions throughout, feel free to submit any that you have, and we'll save about 10 minutes at the end to cover as many as we can. And then we'll also be recording today's session. So if you can't stay for the whole thing, don't fret. We will send out an email probably in the next day or two. So be expecting that. And then you're always welcome to share that and forward it along to others on your team as well. Now moving on to the agenda. So we're going to start with just some basic introductions to our speakers in addition to IBM Kubecost. From there, we're going to move into the kind of core FinOps challenge for Kubernetes specifically and what makes it so difficult. Then we're going to move into some strategies you can actually take for making your Kubernetes more accountable. And then we'll actually go into IBM Kubecost and show how Kubecost can help solve some of the things that we discussed today. And then finally, we'll save some time at the end for a wrap up and Q&A. Now, moving into our speakers, so you have the whole Kubecost PMM team here today. We have Joe Dahlquist, who is the head of PMM, and he'll be covering some of the strategies that you can cover for getting your FinOps practice off the ground. I'm Dee Zeiss, I'm our senior PMM, and I'll be mainly handling the demo portion today. And then Tracy Yen is also a PMM on our team, and she'll be walking through the FinOps challenges for Kubernetes. And then now just a little bit about Kubecost in case you're unfamiliar. So Kubecost started as an open source project in 2019 to solve the challenges that are associated with Kubernetes Spin. It was actually built by two former Google teammates who worked on Borg, which was the predecessor to Kubernetes. And today we are used by more than 10,000 teams across the globe, and we manage over 5 billion in spend. Kubecost does run on any Kubernetes environment, so whatever Kubernetes flavor you're running, we can support that. So all the major cloud providers, as well as on-prem or air-gapped environments, we got you covered. And we work with some really great companies across a variety of industries, such as some of the great logos that you have there. And we're going to go into a lot more detail about Kubecost, but that just gives you a really high-level overview in case you're unfamiliar. And with that, I will pass it over to Tracy, who is going to talk about some of the challenges that Kubernetes presents for FinOps.
Thanks, Dee. So before we dive into the good stuff on how organizations actually make Kubernetes cost accountable, it's important to understand why this problem exists in the first place. So for the next few minutes, let's take a look at the core Kubernetes FinOps challenges that make cost attribution difficult. We know that Kubernetes isn't exactly an emerging technology anymore. It's not new. It's become kind of the standard for modern applications. So according to the CNCF's 2025 survey, 96% of organizations are now using Kubernetes, and 82% says that it will be the primary platform for new applications. So this isn't a niche technology anymore, and for most organizations, Kubernetes is now a core part of their infrastructure strategy. At the same time, hybrid cloud is also the new reality. About 87% of organizations are running Kubernetes across a mix of cloud and on-prem environments. And so while that provides flexibility, it also creates kind of a real challenge from a FinOps perspective, such as every cloud provider bills differently. On-prem costs need to be modeled separately, and finance teams often struggle to get a single consistent view of spend across all environments. And despite Kubernetes becoming mainstream, efficiency kind of remains a challenge. And Datadog had found that 65% of workloads consume less than half of the CPU and memory that they've requested. In other words, organizations are often paying for resources that aren't actually being used. So while Kubernetes adoption has matured over time, cost visibility and accountability still hasn't really always kept pace. And so that's why FinOps has become such a critical topic in Kubernetes environments. So the next question is going to be, if Kubernetes has become so widely adopted, why is understanding and managing those costs still so difficult? And so the answer kind of starts with how Kubernetes actually works, right? And so here we have shown on the right a simplified Kubernetes cluster. You can see 3 nodes, each running a mix of workloads. Team A shown in blue, Team B in green, and shared services in gray. And so now think about what finance actually receives from the cloud provider, whether it's AWS, Azure, or GCP. The invoice is generated at the node, VM, or cluster level. And that's the level of detail the providers expose. But what they don't tell you is how those costs should be divided among the teams sharing that infrastructure. So if finance asks a simple question like, how much did team A spend last month? The cloud bill alone can't quite answer it. And Kubernetes makes this even more challenging because workloads are dynamic. So pods are constantly being created, terminated, rescheduled, and scaled based on demand. And unlike traditional virtual machines that might run for months, Kubernetes workloads are continuously moving around the environment. So that means resource consumption is constantly changing, which makes allocating costs over time much more difficult. And then now you add hybrid environments into the picture. Many organizations are running either OpenShift, on-prem, ROSA and AWS, EKS, AKS, GKE, and many other Kubernetes platforms across different business units. So each environment reports costs differently, making it difficult to create a single financial view across the organization. So the fundamental challenge is that the bill stops at the node or cluster level, but the actual consumers of those resources are the workloads running inside the cluster. And so without a way to allocate those costs down to the teams, applications, or services, nobody can confidently answer the simple question of who owns the spend. And without ownership, showback, chargeback, accountability, optimization becomes extremely difficult. So next slide. So because of these visibility challenges, engineering and finance often end up looking at the same Kubernetes environment through completely different lenses. Engineering teams are focused on more of the operational outcomes. So they're asking questions like, does this pod container have enough CPU and memory to run reliably? Or is the cluster healthy and available? How do we prevent outages when nodes fail? And so finance teams are going to be more focused on business outcomes. And so they're going to be asking, how much does this application cost? Or are we getting the most efficient use out of all of our resources? So both groups are looking at the same Kubernetes environments, but they're trying to answer very different questions. And because the cost data stops at the infrastructure layer, neither side has a complete answer. So engineering understands the workloads and finance understands the spend, but there's no shared view that's connecting the two. And so that's the main ownership problem. Everyone can see part of the picture, but no one can clearly tie the costs back to the teams, applications, and business units responsible for them. So, if Kubernetes spend has an ownership problem, how do we actually make those costs accountable? And now I'll hand it over to Joe to show us how.
Thanks, Tracy. So I'm going to take you through a few steps that are going to help you get your hands around this. Step one is the foundation. It's maybe the most important step. Without it, you're not going to be able to do the other things that we're going to talk about in these slides that are coming up. But this step is all about making Kubernetes costs accountable. And the foundation here is visibility. So the visibility is going to start when you begin pulling in cost data from everywhere, multi-cloud, private cloud, hybrid environments. For cloud clusters, it means pulling in data about billing and about utilization from AWS, from Azure, from GCP, from whatever cloud service provider in the public domain that you use, and any environments that are also private cloud. You're going to want to include things like discounts, savings plans, RIs, so that the numbers that you're pulling in are going to match the numbers that finance is seeing. If you don't have matching numbers and alignment between finance and engineering in terms of the data and the numbers that you're seeing, it's going to be really tough to move forward. So that's like the first kind of dragon to deal with. For on-prem environments, whether it's OpenShift or something else, you're going to need to make some decisions about how to account for the costs related to infrastructure, to storage, to licensing. You may decide that those are all shared costs and they should be divvied up evenly. You may decide that you don't want those costs to be a part of your Kubernetes cost visibility and accountability. You're going to have to make some decisions based on what works best for your organization. Beyond the bills, though, you're also going to have to capture actual usage data, real utilization. That usually means installing some kind of a monitoring agent into your cluster so that you can get that granular real-time usage data to be able to align that with the cost that it's representing. The second is that labeling and tagging hygiene is super critical. Kubernetes workloads should be consistently tagged, and those tags should include things like teams, application ownership, any kind of metadata that you use to be able to categorize that utilization and that spend in a way that's helpful to your organization when we get to later steps like allocating those costs back to teams. Without that metadata, you're not going to be able to properly attribute costs, and mature teams, once you've kind of gotten your sea legs under you, will be able to enforce things like this, tagging, labeling, good hygiene around that through things like CI/CD pipelines or admission controllers, so that unlabeled workloads can't sneak in. If you haven't been doing this consistently from the start, this probably also means retroactively going back and tagging and labeling things that don't currently have tags and labels. That's going to be super important in terms of visibility. Third, you're going to need to identify shared resources. These might be system pods or monitoring agents, security tools, daemon sets. These don't necessarily belong to a single team, and a single team shouldn't be responsible for all the costs associated with them, but they do consume real capacity. They do drive real spend. So if you don't want to separate those out and correctly allocate them, costs are going to become misattributed to a team. You're going to start to see an erosion of trust in that data. So figure out how you're going to deal with shared resources, whether that's kind of round robin distributing them across teams evenly, peanut buttering them over everyone, or whether you want to exclude those costs or balance those shared costs based on which teams are actually consuming more of those shared costs. Finally, once you've got workload metadata and you've got usage data, you need a fair allocation method. Typically, node costs are going to get distributed down to pods based on things like CPU and memory requests versus what the actual usage is reported by agents. And that's what turns a flat node bill into something more meaningful that actually accounts for workload level costs and is easy to allocate back to teams. Now, this may look pretty simple, but there's a lot of nuance in each one of these steps. And a lot of it comes down to your organization's infrastructure, your policies, and your processes. They're all maybe going to be different from one to the next. But without this foundation of just clean workload level visibility, Kubernetes FinOps teams aren't really going to be able to get off the ground and do the steps that come next. And that next step really is about driving team level accountability. In that first step, we kind of talked about breaking costs down from the node to the pods and workloads. This second step is about rolling those workload costs all the way back up to the owners, the teams, the apps, the business units that are utilizing them, that are driving cost within each one of those. And the wrinkle is, again, kind of in these shared services. System pods, networking, monitoring, they don't belong to one team, but they do drive cost. You're going to need a clear and consistent policy for how to handle those costs, or the teams are not going to be able to do the math and get the numbers to line up. It's also really important to audit what engineering is going to see in their dashboards against what finance might see in their cloud bill. If those numbers don't tie out, this whole thing starts to lose credibility. Work to ensure that you're accounting for any variance or delta that you might find. It's could be in shared costs. It could be that you've not included things like discounts or savings plans. Get those numbers to align between finance and engineering, and all of a sudden everybody's on the same page and you can move forward. And finally, this is kind of where showback and chargeback start to come in. Now, showback is going to be able to provide visibility without the enforcement, right? You can go to a team, you can even go to an individual engineer and say, this is the cost based on the utilization that your team is responsible for. When you evolve showback to chargeback, it makes it a little bit more real by actually billing teams or business units directly. Now, most organizations are going to start with showback, and then when it's appropriate, they'll grow into chargeback once that model becomes trusted, once those numbers do tie out. The overarching point here is accountability. Once costs get mapped, once shared services are handled fairly, and once finance can validate the numbers and they see the same things that engineering does, the teams really are no longer able to treat infrastructure like it's a freebie, like it's a punch bowl that everybody gets to scoop from. Each team will start to own their own spend, and that's what is going to drive true accountability, but maybe more important, actual behavioral change amongst engineering teams. So in step one, we got visibility. In step two, we got some accountability. This is step three, and this is where we're actually going to drive the efficiency and the savings, and you're going to get the pats on the back. You'll be a decorated hero within your organization for actually saving some cost. The key is that optimization builds directly on those first two steps, and specifically on that accountability step, step two. Once costs get tied to teams, you can start to surface not just how much they're spending, but how much of that spend is actually waste. First step to detecting waste, it includes things like understanding what your idle and your over-provisioned resources are, but also things like abandoned resources, orphaned volumes, forgotten load balancers, or workloads that have been left running after you've migrated away from them. With accountability in spending or in place, you can start to point to team A or team B and say, here's your share of the waste, instead of just here's your share of the utilization and cost. Next comes right sizing. In Kubernetes, it's super common for requests to be 2 times, 3 times, or even 5 times higher than what's actually needed and what's actually being used. Why? Because engineers are incentivized to make workloads reliable, not necessarily efficient. They'd rather over-request CPU and memory so that they can avoid something like an outage. But without visibility into the cost impact of that behavior is going to go unchecked, and more of it will start to pile up. Right-sizing activities are going to bring those requests back in line with reality so that you're requesting and using really exactly what's necessary. At the cluster level, optimization comes down to balance, just like right-sizing containers, but at a much bigger scale. And it means turning node groups, scaling, selecting the right instance types, configuring autoscalers, maybe open source tools like Carpenter or Cluster Autoscaler or Autopilot, or maybe some third-party solutions. But the goal is always the same, which is finding that perfect balance between performance and reliability with cost so that you can reduce the amount of waste that's driving unnecessary spend. Finally, tracking efficiency metrics over time is going to give you a very useful feedback loop. You're going to be able to measure how much spend is tied to productive workloads versus waste. And you can start to show both engineering and finance that the organization is making meaningful progress in terms of efficiency. Waste is going down, good utilization is going up, and that you've struck this nice balance between the two. Big picture for this, visibility tells you where the money's going. Accountability tells you who owns that. And the efficiency is about finding that right balance between performance and cost. And that balance is the ultimate goal of Kubernetes FinOps. And once people start to lean into that, it's amazing how you are able to increase efficiency and reduce waste. All right, so earlier we saw that a lot of organizations are hybrid or multi-cloud. In fact, most of the large organizations that we talk to have been multi-cloud for a decade or more, and increasingly so, they've got hybrid environments where they're running something like maybe OpenShift on-prem, plus they've got cloud clusters in things like EKS, AKS, or GKE. Those teams need a single place to view all of their Kubernetes costs, and Kubecost delivers that through a self-hosted architecture that brings everything together into one pane of glass. In this setup, one cluster is going to get designated as a primary. It's going to be the cluster that runs the Kubecost UI and hosts the APIs. It's also going to aggregate data from all the other clusters, and those secondary clusters only need to run the Kubecost agent, which is a simple collector and emitter, gathering up usage and cost data and emitting it out to that primary cluster where everything can be pulled together and drive that single pane of glass I mentioned. Each cluster can also optionally run a network cost daemon set. That network cost daemon set is going to help you capture the network egress charges, and a cluster controller is going to provide Kubecost write access to your clusters, so you can actually drive savings and automation and do right sizing without always having to have a human in the loop. Kubecost integrates with cloud billing APIs across AWS, Azure, and GCP, while on-prem solutions, whether using OpenShift or something else, can use what we call custom price sheets. That'll allow you to include hardware and storage and licensing and CapEx spend. All of that data is going to roll up to that primary cluster, giving you a unified cost model. This is the foundation, right? A consistent multi-cluster, multi-cloud cost model. Now we're going to dive into how you can leverage this to be able to meet some real-world use cases around accountability, efficiency, and optimization. Dee, I'm going to hand it back over to you for a demo.
Right. Thank you, Joe. So let me get my screen share up here. All right. So now that we kind of walked through the steps you can take to make that ownership more visible, but then also start driving some optimization opportunities, we wanted to show you how Kubecost can actually help you with all of that. So this is our primary overview page here. You'll see that we have Kubecost deployed across a variety of different clusters, including AWS, Azure, GCP, as well as an on-prem cluster via OpenShift. This is a ROSA cluster. So the first step here is, you want to get that basic cost accountability visible for your team. So the best way to do that is through the allocations page. So the allocations dashboard, this is really our bread and butter. This is where a lot of teams start for establishing that just, foundational cost visibility they need to support some show back and charge back reports. So this view is all about seeing your allocated spend. So you're able to allocate your spend across all of your Kubernetes native concepts, as well as specific business mappings like environment, department, owner, product, or team. By default, this dashboard shows costs broken down at the namespace level. And this is a real-time dashboard, so you can use it for those real-time costs, and it also reconciles your costs with your cloud billing provider. So it's a great place to look for seeing previous spend, but also to project future spend. So if you click in here, you're actually able to dig in pretty granularly. So you can filter into the controller level. You can even get down to the actual pod level, and you can go even further into the actual containers themselves. So very granular view here, but we're going to get back to the main view here. So the whole point is, we want to create a chargeback report. So you can get very customizable with the filters. You can select a single aggregation or a multi-aggregation. You can also use customizable filters if you need very specific and/or statements to get down to a more fine-tuned level of detail for the type of report you're trying to build. But for the purpose of this, we're just going to set it as the owner so that we can start to build this first chargeback report. So the way that the labels work in Kubecost is these are backed by Kubernetes labels. And so, once you have your labeling strategy set up for your team, you can upload your labels to your YAMLs, your values YAML, or even just do it directly in Kubecost via the settings page. But this will allow Kubecost to know how to actually allocate those costs by the teams that you have defined and implemented in your labeling strategy. So once you have the correct aggregation you need for whatever particular label you're after, you'll see that the table below then updates and shows those costs broken down however you have it selected. So we're able to see compute, memory, storage, network, load balancers, all those costs broken down by the actual individual things that will be important. But then you also see your shared costs, your efficiency, and your total cost. So the shared cost is the overhead that we intentionally distribute, like across shared namespaces or platform services. And then the efficiency compares the actual utilization against the requested resources weighted by cost. So, a low efficiency can typically point to over requested CPU or memory, while if a value is, close to or above 100%, that can happen when usage exceeds the request or when workloads have usage, but no requests are actually configured. And if we go back over to the rows here, you'll see that since I have owner selected, we have a breakdown by the two teams that we have designated here. But then we also have unallocated workloads and idle. So the unallocated workloads, those are active workloads that don't have label. So it's actually a good way for you to kind of audit and ensure that your labeling strategy is set up correctly, because if you have costs there that aren't allocated, that means you probably have a missing label somewhere that you'll want to go update. And then the idle cost here, that represents paid for capacity, but it's currently sitting unused. You can actually edit how you want that idle cost to show up in your report. So if we go back up to the report filters here at the top, you'll see that we have the ability to separate idle cost out. We can also hide it entirely, or you can even share it by cluster or node. So we're actually going to select share by cluster here. And since the whole point of this is we're trying to build a showback report, what I'm going to do is set the date range to the last month. And this is going to update the table to show all the costs from the previous month so that we can see what team was responsible for those costs. And once you have that set up, and of course the demo is taking a little bit to load, so apologies there. Once the report is filtered appropriately to all the costs that you're trying to get down to that granular detail for your teams or for a specific environment that you might be after, you can just directly export this as a CSV or a PDF. But more importantly, you can save it so you can refer back to it for later. So right now, I'm just going to label this one as D's report, and then we're going to save it. And then once that's saved, you can access all of your saved reports from the left-hand navigation here by clicking reports. So this will give you a list of all the reports that are saved across your Kubecost environment. And we will just filter for the one I created. So you'll see here now have D's report. And you can actually go over to the Actions tab here and schedule that report to send on a recurring basis. So, you can select the interval if you just wanted to send it maybe weekly or monthly. You can designate the format that you want. And then most importantly, you can add the recipients. So it's a great way to have a chargeback report set up on a recurring basis to, keep the teams aware so that they can have that visibility and access to their particular spend. And then if you're simply just viewing this reports page, you can actually click the hyperlink for that report, and it will take you back to the allocations dashboard with all of your settings already preset and loaded. So now that we have the kind of basic visibility you need for chargeback or showback reports, the next step is really getting to the efficiency view. So we have a different report that is called the efficiency report, and this shows you just that. So this report, this is a really great sort of KPI to use for your team because it allows you to see your efficiency over time. And this is really great if you're using, say, Carpenter, or maybe you're using Kubecost optimizations, which I'll get to in a second. But you want to make sure that whatever optimization strategies that you're doing are actually having an impact on your spend. So this is a great report to refer to see how you're making that progress over time. Now, the way that this report is set up, it shows your idle broken down by two dimensions. So first, we have workload idle, and that is the cost of the resources that are requested or reserved, but not actually being used. And we also have infra idle. So that is the cost of the resources that are not being requested or used. And then together, those make up your total idle. And we also have your total cost and your cluster efficiency here. So the cluster efficiency, that compares the usage to the total cost. So it's a good signal of if the resources are actually being used effectively. Generally, we want that number to be higher and not lower. So a low percentage means that you're paying for resources that are not being used. But we don't necessarily want that number to be right at 100% either, because your production environments still need headroom for reliability and scaling. So the right target really depends on your workload and your SLAs. But typically it's good to keep it in, maybe the 50 to 70% range, because you do need to have a little bit of headroom there to make sure that you can still have your reliability. Now, similar to the allocations dashboard, there are a variety of filters up at the top that you can use to get more granular for whatever view you're trying to see. So I'm going to set this one similar to the last one as the last month. And then the table will update so we can see how our idle costs were changing over time. You can also filter it down to specific cluster or label, or even use the customizable filters that you're after. And you can also view the idle distributed different ways. So right now we have it set to show the idle by type, but you could also update to show it by workload or by cluster. So again, this is just a really good next step after the allocations dashboard, because the allocations dashboard tells us the story of who owns the cost, but this report is kind of establishing that baseline for your efficiency so that you can then track it over time and really see what impact your optimization strategies are having on your environment. So now the next thing is we want to move into what are some actual optimizations that we can make. So Kubecost has this savings page. The savings page displays a bunch of different optimization recommendations that Kubecost identifies across your environment. The recommendations are grouped by type, and they're also displayed as these cards alongside their estimated savings impact. We don't have time to go through all of these today, but there are quite a variety of savings insights that are available. So, we have right-sizing node groups. You can manage abandoned workloads. We also have GPU optimization and even the ability to right-size resource quotas. So there's quite a lot available in here. But we'll quickly just go into the right-size container request. So this is a great one that a lot of teams will often start with. The way all of the recommendations are set up is if you click into the card, you'll actually be able to pull up all of the details for that particular recommendation group. And similar to a lot of the other pages we have, there's a variety of filters at the top, so you can filter down to only the recommendations that you're interested in. So you can control the date range. There's also preset profiles if you maybe only want to select development, high availability, or production. But you also have the ability to customize a profile if you have specific utilization targets you're trying to hit. Right now, we're just going to keep this set to production. And then you can also filter it down to specific clusters or labels that you're interested in. Now, once you have your filter set, you'll be able to see a display of all the recommendations that Kubecost has found for you. And if you click into the recommendation, that's where you'll actually be able to see the details for the recommendation. So here with this one as an example, we can see that our max usage for this is sitting around 157 millicores, but the request is much, much higher than that. So Kubecost is recommending to lower this request to 241 millicores, which is about, it's substantially left, only about a quarter of the current request size. And then it's showing that if we take this recommendation, that is estimating a savings of about $30 a month. Now, $30 may not seem like a lot for the grand scheme of things, but once you add up all of these recommendations across your entire Kubernetes footprint, all the clusters you're running, that can add up to a pretty substantial amount of savings over time if you're actually going in and implementing all of these recommendations. But the next step is, how do we automate this? Because recommendation is great, but it's not scalable to go in and actually do all of these manually. But the good thing is Kubecost can actually automate this for you. So you'll see that right here, there's a button that says set up auto recommendations. So you can set up Kubecost directly in this recommendation to run those for you. But we also have an actions page located over here from the left-hand navigation, where you can also just create the action directly here. So the way that actions work is you have to install our cluster controller. So that essentially grants write access to the clusters so that Kubecost can actually go in and implement the recommended actions that you want us to take. Once you have that enabled, then you can set up any action you like directly in this actions tab. You just simply click the create action button. We have two different types of actions available, so request sizing and namespace turndown. Today, we're going to walk through the automated request sizing. So once you open that up, you'll be able to see the page here where you can build out this action. Similar to a lot of the other pages, there's lots of filters, so you can get down to the specific clusters or labels or workloads that you want us to take action on. So you can go in and set up your and or filters to get very granular, to fine tune the areas you want to target. You also have the ability to change the actual configurations for the recommendations will apply. So you can set a look back window, or you can choose a profile based on what you want to target. You can also enable what recommendations Kubecost will make. So you can select, if you wanted to make the CPU recommendations or the RAM recommendations. You can enable both or just one at a time. And then new to Kubecost 3.2 is we also added the ability to synchronize your resource quotas. So if you have an environment that has resource quotas enabled, you'll be able to run the resizing of those quotas and this same kind of resizing workflow all as one. And similar to the request sizing actions above, you also have a specific look back window and profile that you can set for those resource quotas specifically. Once you have your filter set, you can scroll to the bottom and actually see the workloads that match your filters. This is a good way to audit, just to ensure that that the actions that you want to take are actually targeting those right workloads. And then once you can confirm that those look like the right ones, they're good to go, then you can actually set the schedule for this. So the schedule is very customizable. You can simply click when you want it to run. You can even select if you want it to run at this time or if you want to exclude those particular times. This is really important because you may not want Kubecost to be running these recommended actions all the time. So you might want to exclude it to only happen during maybe a maintenance window or exclude certain hours out altogether. Once you have your action set, you can name it and then click Create Action, and then that will actually appear back on the Actions page. So you'll be able to see a list of all the actions that you have set up, what their schedule is, and if it's currently active. And then more importantly, you can actually audit them as well. So if you click on the Audit tab, you'll be able to see all of the different actions that Kubecost has implemented to changing your workloads, whether it be scaling in or scaling out. And you can also export this as a JSON. So if you need documentation for maybe some sort of governance purposes, that is all available right here to you directly in Kubecost. So now getting back to the slides here. So that's just a couple ways that Kubecost can help you do all of the actions that we talked about today. There's a lot more that Kubecost can do beyond that, but for the purpose of today's demo and session, we really wanted to focus on setting that basic getting the basic cost allocation that you need for chargeback and showback, then moving into how you can start to monitor your efficiency, and then actually going in to see optimization opportunities, and then automating the application of those. But if you're not currently using Kubecost today, it's super easy to get started. So you can deploy with a single Helm command. Typically, you can get up and running in about 5 minutes and start seeing data flowing in. As Joe mentioned, it is self-hosted. So we have a free version that has a limit up to 250 cores. So it's really easy if you want to go in and just start kind of getting your feet wet and trying it out before having to go through like a whole procurement process or shifting over to an enterprise version. You can get started with free, just deploy it on a single cluster and start playing around with it to see how it works. And then if you ever become interested in moving to an enterprise option, we do have a self-hosted enterprise option in addition to a fully managed SaaS version. But if you're sticking with self-hosted, it's entirely deployed in your own environment. It is none of the data leaves your environment, so you don't have to worry about any data concerns there. Very easy to get set up and running. We also have a pretty robust community. So if you are ever having any issues with getting it set up or you have questions, you're more than happy to join our community Slack channel, which there is a link for on your console. And that includes people from our community in addition to our staff. So we're always answering questions and helping people out. But we also have our GitHub repo and our IBM docs, so you can go learn more about getting set up and ensuring that you're using everything properly and getting your cloud providers implemented correctly. So just to kind of wrap up here, we started with the challenge. Kubernetes costs, they're shared, they're dynamic, they're transient. That's why node-level billing alone just isn't enough. It doesn't give you the detail that you really need to understand where your money is going inside Kubernetes. That's why visibility around the workload and namespace level is so important. So, we saw the Kubecost allocations dashboard and, breaking down those costs by, different teams and labels. That visibility really is the foundation for Kubernetes FinOps. You're not getting all that information from your cloud provider, so you really need an actual hands-on way to get into the nitty-gritty details to see who owns that cost, who can make the optimizations to start having a better handle on your cost. From there, efficiency is the goal. So it's a cycle. It's not a one-time project. If you're starting at the walk phase, of course, just using the efficiency report is a great way to get started. Getting, your initial chargeback and showback is great, but this is an ongoing process. You need to hold your teams accountable and make sure that you're constantly reevaluating and going through the process of checking those costs so that it doesn't become just a once a month, scramble after you get the cloud bill and you are surprised by the sticker shock of what you're seeing. But then also make that optimization scale. Automation plays a critical role there. We showed how the automated request sizing action can be set up to help engineers right-size workloads. And those features are really important for helping you really accelerate your optimization so that you're balancing cost and performance. But the big picture here is that Kubecost can help bring this all together. So, we can tackle the visibility, the accountability, the optimization, and the automation across your entire Kubernetes footprint. So if you're running, multi-cluster or multi-cloud or even hybrid cloud, we got you covered. You can run this on whatever flavor of Kubernetes that you're running, and really help you make those Kubernetes costs more accountable so that you can align engineering and finance to, that one single trusted view. We also wanted to leave you with some resources here. So if you download the PDF that is on your console there, you'll be able to access these links. So we include links out to our Kubecost documentation site. This includes the Helm command for deploying Kubecost, but you'll also see a link to the documentation for the things that we showed you in Kubecost today, including the allocations dashboard, the efficiency report, and some of those optimizations and automations. We also have a pretty big array of Kubernetes guides on our website. I included just a few here that might be the most helpful for the topic we covered today. The most important one there is Kubernetes labels. So if you don't currently have a labeling strategy, that's a great one to start with to just kind of learn the basics to how to implement proper labeling in your Kubernetes. And we also included a case study for someone who has actually used Kubecost and saw some great impact there. And now if you are already using Kubecost, your feedback definitely matters to us. There's a QR code there for you to leave us a review on Gartner Peer Insights if you're so inclined, and you will get a $25 gift card for your review. This feedback is really important to us because it helps us, guide the product roadmap. We want to know if there's something that is working or something that's not working, because that helps us work with our engineering and product teams to really prioritize what we're focusing on. So we're making sure that we're improving Kubecost and making it work the best, for our actual users. And then with that, we'll open it up to Q&A. And it does look like we've had a couple in the chat here.
Yeah, and I can jump on those ones first. Julio's asking some great questions. What CI/CD integrations are compatible with Kubecost at the present time? All of them, essentially. I mean, there are some closed loop systems where you might get less functionality, but we have extensible APIs that can be used to wire up into any CI/CD platform that you've got. The second question you've got is when an app has an operator, any changes will be reverted immediately. And I think what you're talking about here is something like a GitOps operator. We actually did a great webinar maybe 2 months ago or so on how to easily integrate Kubecost with Argo CD, but you can also use Flux or your GitOps tool of choice to be able to prevent something like drift correction from happening once you've done right sizing. We've even got an integration with GitHub so you can check those in through the normal pull request and approval process so that those things are declared as the correct infrastructure and they won't be reverted during like a GitOps review process. So be sure to take a look at not only the webinar, but the GitHub repo that had some examples and some great starting code that you can use to get that up and running pretty quickly and easily.
Yeah, and just to add there, Joe, Julio, if that is something you're interested in learning more about, there is a link on the console to our webinar landing page. So you'll see the last webinar that we hosted was on that exact topic. So one of our solutions engineers goes through using Argo CD to automate optimizations, and then also how to ensure that drift doesn't occur. So that's a good one to watch. We also have a couple blogs that we've written about that recently. So if you go to our blogs, you can find those. They should be some of the most recent ones that are listed. And then our next webinar that we're hosting in August, I believe, is actually going to be about GitHub Actions. So the previous one we did was about Argo, but the next one it's going to be about GitHub Actions specifically. So that'll be probably a good one to attend if you're interested in learning more.
Absolutely. So we've got a couple of pre-submitted questions too. Oh, go ahead.
Yeah, let's cover a couple of those pre-submitted ones. So the first one we got, which I think this would be good for you, Joe, is how do you truly develop a single pane of glass in FinOps dashboards for multi-cloud environments?
Yeah, that was kind of the first slide that I presented, all about visibility. So you're going to want to essentially connect Kubecost to all of your various sources of Kubernetes consumption and cost data, whether that's the Kerr report from AWS EKS, or whether that is cost and utilization reports from other cloud environments. If you run into environments that don't provide things like public pricing, that don't provide things like the granular cost details, you can use what we call our custom pricing sheets to be able to declare what those costs are. And then based on the utilization, you will magically get cost and utilization from those environments, whether that's on-prem or whether that's something like, Ollie Cloud or another managed Kubernetes environment that doesn't readily give out pricing information over something like an API call. So we've got solutions to cover just about any Kubernetes environment. We're compatible with any Kubernetes environment. As long as that's the control plane that's running underneath your cluster environment, you're good to go. Just by virtue of connecting Kubecost to those, you can quite literally see in a matter of like 5 or 10 minutes, all of that cost data from all of those disparate different environments coming into enabling both your engineering teams and your FinOps teams with things like dashboards, reports, allocation data, and you're off to the races there.
Great. The second pre-submitted question we had was, are you going to cover NVIDIA GPU costs? Now, unfortunately, we didn't have time to go into much detail on that today, but we do have a savings insight for GPU costs specifically. And I'm not sure, Joe, if maybe you could share a bit more detail about that one and maybe what's to come.
Yeah, we work with NVIDIA both as a technology partner and are also proud to call them a customer. We've helped them understand Kubernetes costs and utilization at the GPU level. We're even in the tool showing what GPU efficiency is. We've got some great tools for doing automated optimization, things like time slicing and others. So we are fully compatible with NVIDIA GPU costs, and we're even compatible with some GPU hardware outside of NVIDIA as well. I encourage you to just do a quick either search on our Kubecost docs site, or even just Google, Kubecost NVIDIA GPU optimization, and it'll take you right to that section of the docs, and you can read more about what we're doing for NVIDIA GPU costs.
Yeah, and if you even wanted to dig into the Kubecost demo yourself and see what that looks like, any of you can access our Kubecost demo. So if you just simply Google Kubecost demo, it should pop up, and then you can go to the Savings Insights page and actually click through all the saving insights that are available, so you can actually see what they look like and read a little bit more detail about the GPU savings recommendations specifically. There's only, I think, one that is loaded up in our demo environment, so it's not super detailed, but it should at least show you what it looks like and what's available for you, just to kind of help visualize the docs a bit better. And then now we had one more pre-submitted question, so we'll kind of end with this one and then call it a day. So someone asked, how can we achieve application level cost visibility when multiple teams share nodes, clusters, network, and storage with inherent resource wastage? I think that was a typo. Yeah,
so we touched on this a little bit through the webinar. a lot of those come down to like the shared costs, right? And shared costs are going to vary from maybe team to team, organization to organization in terms of how you want to allocate or spread those shared costs across teams. Maybe you want to focus them on a select group of application teams. Maybe you want to, like I mentioned before, kind of spread those evenly across the teams that are sharing those shared costs. We can kind of divorce that from solving for the inherent resource wastage problems, which is we have tools, visibility, and even automated actions to right size and solve for the waste that you're going to find in shared resources. We even have tools that are going to bring those to the surface so you don't have to go through the arduous process of hunting and looking for where that waste might reside. Kubecost will actually surface that for you in our savings pages. So think about that as maybe two separate activities. One is you're going to have to figure out how to spread shared costs across the team so that from a showback, chargeback, or allocation standpoint, they're accounted for in the mix of all of your Kubernetes related costs. And then secondarily, you can work with either teams that are responsible for infrastructure, whether that's a platform engineering team or maybe something where you've got that one person where everybody is standing around their desk because they know lots of stuff about Kubernetes. Those individuals are going to be able to help look at the savings recommendations that you've got for waste that's happening in those shared resources, whether that's network at a cluster level or shared nodes and services, and be able to do right sizing capabilities to reduce that waste and increase your efficiency.
Great. Yeah, and as I mentioned before, we do have a Slack community. So as you're starting to dig into Kubecost and get started, if you have any questions as you start to go, actually get it deployed and get it integrated with your cloud providers, we're more than happy to answer any questions that you have. But you can also reach out to our team directly via email. Our email is team-kubecost@ibm.com. So feel free to email us with any questions you have, and we're more than happy to help you along your journey of getting Kubecost set up and implemented. But with that, just wanted to thank you all for joining today. Hope you have a good time, and be on the lookout for the email with this recording if you want to share it with others. And also, we'll send some details for our upcoming webinar that's happening in August that I mentioned that will be about GitHub Actions. So we'll end there, but thank you so much. Hope everyone has a good rest of your day.